Okay, today I want to talk about the remaining part in the section 1.4, vector equation, the matrix equation AX equals B. Let me see. Okay. This problem show that the matrix equation AX equals B does not have a solution for all possible B, and describe the set of all B for which AX equals B does have a solution. The matrix A is given, the vector B is given. So how can you do that? So first, you can change this one to the augmented matrix. So what's like augmented matrix? I can write here. The augmented matrix is, you can keep matrix A, the 1, this is negative 2, 4, negative 2, 2, minus 1, the negative 1, 0, 3, the vector B is P1, P2, P3. Change it like this. This is augmented matrix. So we can use echelon form. You can change this one to the elementary row operation. So you can change it. So first, this is the first row and the second row. How can you eliminate the negative 2? Like this one. This is second row. Second row plus 2 times first row. The second row is negative 2, 2, 0, P2. The 2 times the first row is 1 times 2 is 2. The negative 2 times 2 is negative 4. The minus 1 times 2 is negative 2. The B1 times 2 is 2B1. And add it. So we have 0, negative 2, negative 2, 2B1 plus B2. This is like second row. The next, you can eliminate the 4 in third row. How can I eliminate? The same method. This one is the third row plus the negative 4 times first row. The third row is 4, negative 1, 3, B3. Minus 4 times 1 is 1 times minus 4 is negative 4. Minus 4 times negative 2 is positive 8. The minus 4 times minus 1 is 4. The B1 times minus 4 is negative B1. 4 times B1, sorry. Negative 4 times B1. Next, you add it. This is 0, 7, 7. This one is negative 4B1 plus P3. So what's it like echelon form? This one. This is like equivalent to this one. So you can keep first row 1, negative 2, minus 1, P1. The second row is 0, negative 2, negative 2, 2B1 plus B2. The third row is 0, 7, 7, negative 4B1 plus B3. So like this. The next, you have to eliminate the 7 in the third row by using second row. How can you do that? I just write here. The next one is this one. The third row plus 7 over 2 times second row. The third row is 0, 7, 7, negative 4b1 plus b3. The next here, 7 over 2 times second law. So what's that? 7 over 2 times second law is 0, negative 7, negative 7. The 2b1 plus b2 times 7 over 2. Exactly. The here 7 over 2 is 7b1. 7 over 2 times b2 is plus 7 over 2 times b2. Next, add. So what's that? 0, 0, 0. The minus 4b plus 7b1 is 3b1 plus 7 over 2 b2 plus b3. So argument to the matrix is you have to keep first law 1, negative 2, minus 1, b1. The second law you have to keep 0, negative 2, negative 2, 2b1 plus b2. Third law is 0, 0, 0. The last one is 3 b1 plus 7 over 2b2 plus b3. So what's it like this one? So we have a pivot in each law. This is 1 is a pivot, we have 2 is a pivot. Third law, this kind of things. What's it like a third law? So you have to change it to the linear equation form. The third law is like this. 0 times x1 plus 0 times x2 plus 0 times x3 equals 3b1 plus 7 over 2b2 plus b3. So we have this kind of things. So we have a solution or not, depending on 3b1 plus 7 over 2b2 plus b3. So we have this conclusion. The if 3b1 plus 7 over 2b2 plus b3 is not equal to 0. So for some choices of B, the choices of vector B, so what happens? So AXB does not have a solution. Have a solution. Does not have a solution. But if this one equal to 0, for some choice of B, what happens? AXB is consistent. So AX equals B has a solution. So in this case, we have infinity many solution because we have 0x equal to 0 form. The solution, so usually infinity many solution. So what is the final answer? So you can describe the answers, the next one. What is the answer? This is like a solution set. What is like a solution set? The solution set is you can keep B1, B2, B3. This is not a solution set. This is not X value. So this is like what is it like set of all B is right. The set of all B is like this. The set of all B is B1, B2, B3 such that 3B1 plus 7 over 2B2 plus B3 equal to 0. So in this case, we have a solution. This is answer of this equation. So this is the whole idea for solving this problem. So next, span of a column of A. So what does it mean? This is the definition. The column of A. This is like a typo. The columns of A. Here, this is like a typo. Here, the columns of A span Rn. What does it mean? So every vector be in the Rm is a linear combination of the column of A. So note that M is number of rows in matrix A. So like this. So what's it like exact meaning? The here. So this one is first row. I can write A1. Vector A1. The second row, we can write vector A2. This is vector AN. So we can write this one to the vector A1, vector A2, vector A3, so keep going, vector AN. You can write like a form. So what does it mean? The columns, this is like a type I said before, the columns of A span Rm. So what's like exact meaning? So like this. So for every B, for every B, vector B, so what does it mean? So we have this kind of forms. x1 constant times vector A1 plus constant x2 times vector A2 plus keep the xn times vector an. So exactly same to vector B for some vector x. Vector x is x1, x2, xn. So this is exactly the columns of SA span Rn. This is like exact meaning. The exact meaning. So in other words, like this one. You can change this form to the matrix form. What's that? You can change vector A1, vector A2, keep going, vector an times vector x equals vector b. So what's that? It's the same to a times x equals vector b. So ax equals b has like some solution x. So exact meaning is the ax equal to b has a solution. Has a solution for any vector b. This is like one. Vector b, in Rm, like this one is right. This is like the exact meaning. So we have this kind of things. So here, from the previous example, the columns of A do not span R3. So why not? Here, remember? So you have to choose some choice B, such that 3B1 plus 7 over 2B2 plus B3 is not equal to 0. So what happens? AX equals B does not have a solution. Does not have a solution here. So we have next one. The AXB does not have a solution for some B. So what does it mean? So columns of A span but does not span Rm. They do not span the Rm. This is like the exact meaning. So like this. Why? Ax equals b did not have a solution for all possible b. The previous example. So what happens? So the 3b1 plus 7 over 2b2 plus b3 equal to 0, so we don't have a solution. It's right here. Next one. Not equal to 0, we don't have a solution. We only had a solution for values of b that satisfies 3b1 plus 7 over 2b2 plus b3 equal to 0. So what does it mean? The last row of A did not contain a pivot. So this means here. Here. So this is a pivot. First column has pivot 1. Second row has column -2. Third row. So in this case, the last one equal to 0. What does it mean? We don't have a pivot. The last row doesn't have a pivot, so we don't have a solution for some b. It's like exactly. So like this. This is a very useful thing. The last row of A did not contain a pivot. What does it mean? The columns of A didn't span Rn. Geometrically, the solution was a particular plane through the origin, not all planes in R3, like a geometry, this kind of things. Here. Determine if the columns of matrix A span R3. I want to use this one. Some row did not contain the pivot. What does it mean? The columns of A did not span Rn. So we can use this kind of things. The problems are like given like this. So you can change this one to the like here. Change it to the echelon form. The echelon form I can change. You can change it to the echelon form. So what's that? This is like the -3 is top. Change, interchange first and the third row. The -3, this is 9, -6. The second row is 0, -3, -2. The last one is 0, 0, 4. Is right? What happens? What happens? Every row has pivot. Every row has a pivot. The first row has -3. Second row has -3. Third row has 4. So here, every row has a pivot. What's your final answer? The Ax equals B has a solution. So matrix A span R3. That's it. This is the whole idea for solving this problem. They're not difficult. We can check the pivot one. Every row's pivot one. So this is like a summary. The matrix A is n by n matrix. Then the following statements are logically equivalent. The Ax equals B has a solution for every B in Rm. So every vector B in Rm in a linear combination of the columns of A. The columns of A span Rm. This is always the same. From previous example, previous explanation. The matrix A has a pivot in each row. This is all the same. So note, when we say the above statements are equivalent, we mean that for a given system, if one statement is true, then all 4 statements must be true. If one statement is false, all 4 must be false. This is exactly. This is a very important thing. So we can use these kind of things a lot. I will give one more example here. Determine if the equation ax equals b has a solution for every b in Rm. How can you check this kind of things? So I want to use this one. This is very useful. The matrix A has pivot in each row or not. You can check. So you can change this one to the echelon form, the same. I can change this one to the like this. Here, the first, you just only eliminate -1 and 2. How can you do that? This is like a first row. This is a second row. This is a third row. This is like a first row here. Second row plus first row, you calculate. So we have -1, -1, -1, 1 second row, plus the first row, 1, 3, 0, 3. You add it. So we have 0, 2, -1, 4. So we have it. So you have to keep the first row, 1, 3, 0, 3. Second row is 0, 2, -1, 4. The third row, this is also 0. You don't need to change it. 0, -4, 2, 8. So we have it. The next third row, I can do that here. The first row plus -2 times first row. The first row is 2, 0, 3, -1. The -2 times 1 is here. The -2 times 1 is -2. 3 times -2 is -6. 0 times -2 is 0. The 3 times -2 is -6. You add it. So 2 rows, 0, -6, 3, -7. So we change 0, -6, 3, -7. The next two. So you have to eliminate the -4 and the -6. How can you do that? You can use similar method. Here, this is first row, second row, third row, first row again. You have to keep first row. 3, 0, 3. You have to keep second row. 0, 2, -1, 4. So how can you do like a third row? Like this. Third row plus 2 times second row. The third row is 0, -4, 2, 8. The 2 times the second row is 0 times 2, 2 times 2 is 4, the -1 times 2 is -2, 4 times 2 is minus, this is 4 times, right? It's like this one, 8. You add the two equations. So we have 0, 0, 0, 16. So we have 0, 0, 0, 16. So we have it. The next one. This is like first row plus 3 times second row. The first row is 0, -6, 3, -7. So 3 times the second row, this is like 0. 2 times 3 is 6. The -1 times 3 is -3. The 3 times 4 is like 12. So we have it. You add it. What's that? 0. Here. 0, 0, 0, 5. We have 5. The next tip. This is first row, second row, third row, first row. So we can eliminate 5 by using second row. How can you do that? So like this. You have to keep 1, 3, 0, 3. 0, 2, -1, 4. 0, 0, 0. I want scaling is better. So multiply third one times 1/16, 5 times 105, just scaling, 1, 0, 0, 0, 1. The next, so you have to, like this. This is the first low and second low, the third low, first low again, the first low plus -1 times third low. So what happens? The 0, 0, 0, 1 is the first low. The -1 times the third low is 0, 0, 0 times -1 is -1. Add these two equations, 0, 0, 0, 0. So we have this one. 1, 3, 0, 3. 0, 2, -1, 4. 0, 0, 0, 1. Last one is 0, 0, 0, 0. So what happens? The first low has pivot 1. The second low has pivot 2. The third low has pivot 1. What's the last one? We don't have a pivot. The last low does not have it. Does not have a pivot. So what does it mean? A, X, B does not have a solution for some vector B in Rn. This is like R4. Okay, this is like a whole idea for solving this problem. So this is like all for today lecture. You can watch this video by yourself. Any trouble, any question, let me know. I can explain the more things like later. So thank you for watching my video.